Okay, so I'm not going to go through the proof on the side, but I'm going to talk about just the sine graph. I just want you to look at this one. At that point there, what is the derivative? 0. So if I was to do that, I would plot that point right there. Okay, so you know how we were graphing derivatives? We're graphing the derivative below. Here we also have a derivative of 0. The slope is 0. So we're going to put it there. So remember, when we are graphing the slopes below, graphing the slopes is graphing the derivative. Now at this point here, slopes are all positive, but they're getting closer to 0. So that's it. We have positive getting closer to 0. These are all negative. And here is going to be the most negative it is. That's going to be the steepest negative slope. So this will be a min, which is right here. And then we still have, so this is negative slopes. Okay, so it goes there, and then the negative slopes get less and less. And then we've got positive slopes here again, which is this part. So you can see below is the graph of the slopes. And in the graph of the slopes is the cos x. So the derivative of sine x is cos x. Yeah, like I said, I think the pre-calc is probably the hardest part of this unit, not the calculus part. If you take a cos graph, and again, we have that's 0. These are all negative slopes until this will be the max, or the greatest, steepest negative slope. So this will be our min. And then we have another, there's a slope of 0 there, and a slope of 0 there. And these are all max slopes. So this would be a max here. Okay, so this kind of takes you back to the when we were graphing slopes. Now this gives you kind of an identifiable one. This one you probably identify more with, because that dotted one is sine x. But this is a reflection of sine x, so y equals negative sine x. So the derivative of cos x is negative sine x. Again, you do not have to memorize those. If you go to your trig function derivative, there's sine and cos right there. It is the derivative of sine u is cos u du over dx, and cos u is negative sine u du over dx. Okay? Yes. Okay, so let's go and do some. How would I find the derivative of cos negative 4 pi? So when you're doing these, you want to kind of be using the chain rule. Okay? Chain rule is not as bad as the product rule or the quotient rule. So you just want to keep going until you've worked all the way to the inside. So the first thing you want to do is the derivative of cos x. So dy over dx, that would be negative sine, and you keep the u inside. It's negative sine u du. So then I have to do the derivative of the inside, which would be, oh, sorry, it's a typo. I don't have, this is supposed to be an x, or else you're right, it would be 0. So this is supposed to be an x. Okay, so this would be times negative 4. So this would equal 4 sine negative 4x, because the negatives cancel. Now, when we do these, we don't leave negative angles. Okay, we always have to make the angles positive. And we know that on our first negative angle identities, negative sine x equals sine negative x. So if there's a negative inside there, it is the same thing as pulling it outside. So your final answer would be negative 4 sine 4x. So chain rule, and then after you're done, make sure there is no negative angle. Okay? This one here. Now, where these are kind of different is that when you have a number in front of an angle, sine, cos, tan, we actually just keep that number. So dy over dx would equal 4. And then I would do the derivative of sine, which would be cos negative 2x squared minus 3. So sine u is cos u. The u stays the same. Then you kind of apply the chain rule, and that would be times negative 4x. Okay? That would give me negative 16x cos negative 2x squared minus 3. Now remember, not allowed negative angles. Now the one I know is cos x equals cos negative x. But this one isn't really in the form negative x yet. So we do want to take a negative out. So you just don't want to look at this negative in front here, okay? It all has to be negative, so you got to take that out. So that's one important thing that we want to make sure we're always doing. And then that would just be negative 16x. That's asterisk. And that would be just cos 2x squared plus 3. No, look. You just get rid of it. Yep. That's different than this one here, where this actually comes out front. This just goes bye-bye. Okay, C, I want to write what C often gets mixed up with, and this does not equal sine 3x squared. Okay, those are not the same, because I would do the derivative very different on the one I just wrote out. So just realize that 2 is only talking to the x, not to the entire thing. Okay, and then this is the same as sine squared 3x, right? These mean the same thing. So we would do the derivative on that very differently than we're going to do on ours. Ours, we're looking at basically this scenario here. That's all isolated within the angle. So dy over dx, the sine is cos, and again you want to write that out because it's cos u times du over dx, which would be 6x. So this one works out to be 6x cos 3x squared. Okay, so D is a very good example to have next because that one looks similar. In fact, most people don't mix this one up, though, but in C, they think the whole thing is squared. So just remember, this is the same thing as y equals, and I actually take the time to write it like this because it makes more sense to me, and I don't, and then I'm thinking the chain rule, right? Now, the first thing we do, we can't even work with the sign yet. We're just going to dy over dx equals 2. sine 3x. And you could put a 1 there if you wanted to. You don't have to. And then derivative of the inside would be, what would it be? No, all of this cos 3x times 3. Okay, so you keep working from the outside in. So you didn't seem to like that too much. First did this on the outside, right? Then I had to do derivative of this. Then I had to do the derivative of this. Because I had to do the derivative of this. Remember, it's derivative of this. Cos 3x would be, or sorry, sine 3x would be cos 3x. And then you have to do the du of dx. Just like we did here, right? 3x squared. I did this to get 6x. Okay, so now this is kind of a pretty tricky question because most people they would take the 3 and they would bring it out front and they would get 6, right? Where this could be a pretty evil question is if it was a multiple choice. And would you see this as sine 2 times 3x? That's an identity on your identity sheet. So just write formula sheet here, so when you're looking at it later, you're wondering, see what you did. And then we still have that 3 out front. So this would equal 3 sine 6x. The identity? Yeah. Okay. Okay, so it's the identity is sine 2x equals 2 sine x cos x. And my x is 3x. Okay, what's unique about E? We got to use the product rule. We don't have to use the quotient rule. You could, but you could rewrite this as y equals x cos x to the negative 1. So because we have two things multiplying, we're going to have to use the product rule. So product rule is derivative of the first times the second plus the first times the derivative of the second. So the first thing, cos x to the negative 1. Cos is negative sine x to the negative 1. And then I've got to do the derivative of this yet, which would be negative 1x to the negative 2. Okay, oops, I should say dy over dx. And then this would be 1 times cos. That would just be cos 1 over x plus. Now, we've got two negatives here. They're going to cancel. So I'll have a positive. And this is the same thing as 1 over x squared, right? So then I have x over x squared if I bring these two together. Sine 1 over x. Yeah, I got to do that yet. Okay, and then I could get this down to be 1 over x. Okay, so f, remember, we want to use the chain rule. We're going to work from the outside in. So dy over dx, the first thing I'm going to bring my 6 down. So that would be 6, 1 plus cos, and maybe I'm going to write it like this, cos x squared to the 5. Okay, now if I do the derivative of the inside of those brackets now, what would I get? Good, 2 cos x, right? No, it would be like I haven't done, I did the outside here, right? Now, I'm going to do the derivative of this, which is negative sine x. So I did this one first, then I did that one, and then I did this third, right? I worked from the inside out. And if that was x squared inside, then I would be doing a 2x yet. Okay, you just kind of keep working, do derivatives from the outside down to the inside. Okay, and now you got to clean up the mess. That's an equal sign, not a negative. So then I would get, okay, I do have a negative out front here, so that's going to be negative 6. Now, here's another one that I don't know what if a lot of people would see that. If I get the negative out of there, what does this equal? Sine 2x. Should be, right? Okay. So this negative I brought over here. Yep. Yes. Yep. Yeah, you've always got to do the derivative of u, the inside. Okay. Oh. Find the equation of the tangent line to the curve y equals sine x over cos x. So the slope, right? Now, we need the slope, sorry, to find the tangent line. This one, it's just kind of a nice question to use because we have to use a different. So if I got y equals sine x over cos x, I would have to use what? The quotient law, right? So dy over dx. So it's low derivative of high, which is cos x.
So you wouldn't want to change that for x?
Not today. Tomorrow you can. Yeah, you're always out of the game. Okay, and then minus the top, or no, low d high, high is sine x times d low, cos x is negative sine x, all over low squared. So it'd be cos x squared. So this is kind of leading up to when you do the derivative of tan. But this is a good proof, right? If it just said prove this derivative, okay. Now, this gives me cos squared x. Because of these two negatives here, that would give me plus sine squared x all over cos squared x. Now, some people, especially on that last question of the quiz, some people are trying to cancel like here, and you can't do that. You can only cancel when numbers are multiplying together, never adding, okay? So you can cancel factors, but you can't cancel terms. So you can't do that. But this equals 1 over cos squared x. Okay, which is secant squared x, right? And you can see even if you go to your tan is secant squared x. Okay, but we want to try and solve the slope at this point. So we're going to put in, so the slope would equal 1 over cos pi over 4 squared. Okay, I'm just going to draw it here. Pi over 4 is root 2 over 2. That's what cos is there. So it's the same thing as 1 over root 2 over 2 squared, which is 1 over 2 over 4, which is 1 divided by a half. 1 divided by a half is 2. Okay, so your slope is 2. So I know my slope equals 2 at point pi over 4 comma 1. So let's use our y minus y1 equals 2 times x minus x1. That would give me y minus 1 equals 2x minus pi over 2. Now, we don't want any fractions, so I'm going to multiply everybody by 2. So it'll be 2y minus 2 equals 4x minus pi. And then I'm going to get everything, doesn't matter on the left, on the right. I'll get it on the right, so 0 is 4x minus 2y plus 2 minus pi.